the Data channel, and you're watching SQL Bootcamp for Data Professional. And as part of the topic 10, we will be discussing about the subquery versus join. So if you are familiar with the SQL, you might have definitely heard about subqueries and also joins, but often there would be a thinking or thought process that how this can be used interchangeably, or can they really be used interchangeably, and what are the consequences of doing that. So we will discuss that in this video with certain examples, real-time examples, so we will understand this subqueries versus joins in SQL in much better way. So before proceeding, if you're new to the channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So basically, before we jump to the differentiation, so let's understand what exactly the subquery is and join is. So subquery is nothing but you are creating a query nested inside another query. Okay, it can be multi levels also. So nested query need not be one level. So there can be a query inside query one inside query two, and then again query 2 inside query 3, and so on. So there can be multi-level of nesting that can happen, and it is basically is used to retrieve the data that will be used in the main query, that is referring query from the referee query, right? So there will be a child query which will be returning the values to the main query, and that the returned value from the child query will be used in the main query. So let's take an example here, right? So as you can see in this example, there is a select star from employee where department ID equals to something, but that something is coming from where? It is coming from the subquery. So subquery starts with a brace and ends with a brace. Okay, and as you can see, you are selecting department ID from department where department name equal to HR. So basically you are getting the department ID where the department name equal to HR, and then so that it might be like 100 or something, so that department ID 100 will be returned here, and then you get all the employee names which are belonging to the department HR. So that's how the subquery. So as I said, right, so there can be different level of subquery. You can write one more subquery inside this, and whatever it can be like a different level of complexity. Okay, and the join is simply combining the rows from two or more tables based on a related column between them. So definitely join is between multiple tables. Sometimes it can be with the same table, so that we call it as a self join, but generally it is with a multiple table, even though it is a self join, right? So you are creating you are actually making that table exist two times virtually, and you are joining between those two tables. Again, that is logically it is actually two or more table only, okay, on related column between them. So that join can happen only and only when there is a related column between them, like just like a foreign key and primary key, or there is a some relationship between based on some keys, right? So that can be happening using something similar to this, where you select star from select some columns from employee table, so then do a inner join. Okay, inner join on department table. So on like employee dot department id equal to department dot department id. So basically what we are trying to here, so you want a department name in your query. So the department name is not there in the employees query, so that is why you are joining this particular table, employee table, with the department table, so that you can get the department name. So basically every join will expand its selection criteria to the other tables. So previously without this join, the selection criteria was only the columns which are there in employee table. But now that you have joined with the department table, so you expanded your capability to get the all the columns from the department table. But the only important thing is there should be some common ID or some common key that exist in both the tables, which will join these in a unique way. Okay, so that's about join. So the SQL subqueries and joins, right? So now let us see what are the actual advantage and disadvantage of using subqueries and joins. So starting with subqueries, the advantage is definitely the readability, as we saw. So it's a programmer friendly, and anyone who reads that it can easily understand what exactly happening, right? So in the subquery, we tried to get the department ID, and that department ID was passed to the main query. So to get the all the employees belonging to the HR department. So that's where that becomes more readable and also modular. Okay, modular because it's useful when you need to isolate a part of your logic. So there is a complex logic where you have built doing xyz different activities, and x can do perform some activities, y can perform certain activities, and z can perform certain activities. So all these three different queries can be inner joined or related with the inner join criteria, so that that become modular. And nesting, as I said, so subqueries can be nested at multi-level deep, so that can go from one level to n number of levels. So that's also one of the advantage. Okay, but in a similar way, there are disadvantages also when you are using subqueries. When you consider performance, so performance are usually less efficient. So subqueries are very usually less efficient than joins, especially for the large data set. So this is quite important here when you're thinking about the differences, right? So this is pretty important because so you need to understand what is the volume of the data that you're working in. So if there is a large data set that you're performing subquery, so then it is a caution. Okay, so then it is a different warning, I would say. Okay, we need to evaluate that, because and also you need to take care of a situation where the data is growing. So even the data is growing, if you are using that particular table in your like nested query, so eventually that down the line 3 years or 5 years, so the data volume might spike up. Okay, so that is where it becomes challenging, right? So the data volume can spike up, and that volume which is spiking up, that can impact the performance here as well, right? So why that happens? Because the subqueries must be executed separately for each row, right? So it has to be executed for each row. So that is because of that reasons the performance is very bad if you are using with a large data set or growing data set. Okay, and like limited flexibility. So this is because you may not always have the ability to use a subquery for the complex retrievals. So might be like, yeah, it might not be having that flexibility where you can just go ahead and use it everywhere. Okay, like similarly coming to the joins. So joins, the performance definitely it is having very good performance, and it is really good faster irrespective of whatever the number of records you have, right? Unless you are writing a syntactically good code and you have a good CPU and memory utilization for the data set required. So then there would not be any performance issues. Okay, and so that reduces the number of queries to be executed. Okay, because it applies on the table, unlike subquery which applies on the each row. Okay, and versatility, join so provide more flexibility for complex queries, especially when dealing with multiple tables. Okay, you can have, as I said, right, so you can have A joining with B, and again B joining with C. Okay, so that can create a complex query operation, and it can go on. Okay, and its efficiency is why we are calling it as efficiency, because useful for large data sets since they do not require multiple execution like subqueries. Okay, so suppose there is a table A joined with table B and table B joined with table C, all the execution happen at once. Okay, but in the subquery, so table A like the subquery first, C will execute and it returns a value to B, then B will execute then return value to A in terms of subquery. So that is why it is a performance wise it is very bad when you consider the large data set. So what are the disadvantages, right? So the complexity. So if you take about like there might be 10 plus kind of a different joins that you are making, and the joins can be conditional joins along it. It is not just about the ID joins, but you're also adding more conditions to that. So that can like sometimes become more difficult to read or maintain over the time because of the complex query that involves multiple tables. So it's not quite intuitive like subqueries joins, right? Because it actually has um, execute at all at once. Suppose there are 10 different joins you are making, so all the joins execute at once. So here the subqueries is logically that, so there is a hierarchical, right? So A and then B and then C. So it's hierarchical. Okay. So but joins are like everything parallel it works. So it's sometimes easy, difficult to kind of understand the complexity. And the next is the result set. So joins may return more values than expected due to a Cartesian product. So there is a risk of Cartesian product, especially with the cross joins or so incorrect and on conditions basically. Okay, and like if there is a data quality issue, so even in that case, a join can be um, uh, really can give the very unexpected results. Okay. So next, when to use what, which is important, right? So use subqueries. Okay, so if you are taking notes, this is important. So use subqueries when you are working with isolated data fetching logic, need a aggregation or just a query specific data points for a smaller data set. So this is first criteria, smaller data set. And second is specific data points. You are looking for querying the specific data points. Like previously we were just looking for the department ID. Okay, so and needs aggregation or just this thing. Okay, working with isolated data fetching logic. Isolated means there is, as I said, there is a B query and then C query, right? So all this logic are isolated, so there is no dependency. C is just executing something and giving something to B, and then B is executing and giving something to A. These are isolated logics. Okay, unlike join, which are um, uh, completely uh, completely where you have the parallel logic which executes, right? So next is use joins. So when like the main thing is again the larger data set and you have a complex queries, right? And when you combine the data from multiple tables. So these are the keywords basically. Large data set is there, multiple tables is there, you have a complex query to write, and especially you are writing in a use case where you have a analysis or reporting. Okay. So these are the important points. So let's quickly jump to the practicals and let's understand this in much better way with practicals. We'll jump to the practicals with two tables here. So one is a department table. So there is a department ID, department name, and then there is a employee table which is referring to the primary key of the department table as a foreign key in the employee table, right? So which is the department ID. So this 101 department ID is nothing but if you go, it's a HR department, right? So similarly, you can see a salary and hire date in the employee table. So with this, we will quickly kind of take one of the use case. Okay. So we can take a use case where we want to find employees who work in HR department. So this is again we similarly we saw in the discussion, right? So using subquery. So here we don't need to combine the multiple tables. It is just one table. Okay, so that one table need to be employee table, and you have a department ID. So department ID we know, uh, so we just need to find, so here we need to give the department ID as 101, but that is if you know. But if you don't know, so then you have to kind of get this from the department table separately. So this is isolated logic that we are calling. Okay, so that isolated logic will be something similar to this, where you can just run this and see isolatedly. So you will get the 101 for the department HR. So this 101 will be returned to this department ID as 101, right? And that will give the employee list of employees who are part of the HR department. So simple as that. So why we are using subquery here? Because you are fetching a single piece of information, that is department ID, from the another table using the filter operation on the employee table where condition, right? So this case is simple and modular. We are actually having a modularity here, and it is simple, and both the logics are isolated. So that's why you can simply use the subqueries, and it is easier to write and understand when you are just looking for specific conditions rather than pulling related data from two or more tables, right? And let's consider one more case where we say retrieve the names of employees and their corresponding departments. So in this case, we need to have the join condition. The reason why is you are combining the data from both employee table and department table here. Okay, and the inner join ensures you only get the employees who are part of the department, making it more efficient for combining the tables. Okay, based on the key, that is department ID is the key between these two, right? So let's see how the code might look like. So we have an inner join here. Okay, and based on what? Based on the department ID, definitely, because e dot employee also we have a department ID, department also we have a department ID, and employee name is coming from employee table, so we wanted department name, right, for each employee. So that is not in the employee table, so that is why we have to go to the department table to get that. So that is why there is a join. So you can see, and why inner join, right? If you give just like a left join, for example, you still get a value 60 values here you are getting, right? Here also you're getting 60 values, but it again logically depends on the data. But here the data might be good, so you're getting all the results. But sometimes if the left table is having nulls, so the employees, or the right table is having there is no match conditions between, so then you might end up having nulls in either in employee or department table based on left join or right join that you use. So it's always, in this case, it's always better to use the inner join, because you want to ensure you only get the employees who are part of the department. Okay, so in this case all are part of the department, so it is not making difference whether you use inner join or left join. And so it's also more flexible and scalable for pulling data from multiple tables, so that's why we are using here the join instead of any kind of subqueries. Okay, and when a subquery is preferred over a join. Okay, so let's take another example to understand this. So we have a use case where we want to find the employees with the highest salary in each department. Okay, for this you could use a correlated subquery. Okay, so correlated subquery means a join would be a complex here, since you are making with group based criteria. So basically it is simple to use subquery. Here you are just getting the maximum salary, max of salary from the employee table, where department ID equal to e department ID. Okay, so basically here, even though there are two different tables involved, you can see employee table is involved, and then there is a department ID. Okay, department ID equal to e dot department ID, which is coming from correlated subquery. This is called correlated subquery. Okay, so let's try to execute this. So here you are getting the result. Basically e dot department ID is employee is coming from the outer table, right? So it is cleaner when you need to compute aggregated values like max of salary for specific groups of departments without complicating the things with the joins. Okay, here you could have done using joins, but here you don't want to use the complicated thing, so that's why you are making a correlated join. So this is not actual join, which is a this is a logic part of the subquery. So this correlated subquery matches each row from the outer query, that is employee query, to a condition based on grouped criteria, that is highest salary in each department. Okay, so that is why we call it as a correlated subquery. So this might be looking complicated sometimes. Okay, but let's break it down more, right? If you have questions, you can still feel free to comment in the comment section. But so here you have a employee table, you're taking max of salary, that is clear, but only on the condition where department ID equal to e dot department ID. Okay, that means there is a department ID in the employee table, and you want to get that matched with the e dot employee table, that is outside there is a table, so you want to get it matched. Okay, so only then you want to get it. So when a join is preferred over subquery, so this might be a another question, okay, which might arrive. So in this case, like let's take another use case where join is preferred solution rather than using subquery, right? So a join works better here in this case where you are having this case, right? So where we want to retrieve employees and the department information for only those in department with average salary greater than 6,000. Okay, so here join works better because you need to combine the department table and apply aggregating a filter condition. Okay, that means let's take this code now and break it down. Right, so what we are trying to do is, first of all, we understood we have to join a department and employee table. Okay, so we did a department and employee table join here. Okay, based on this inner query condition. However, after that, so again we have a department ID. Okay, we are using department ID because department with the average salary greater than 6,000. There is a condition again. Okay, so then we need to kind of get that average salary. How do we get each department? So department ID, you need to get all the department IDs from the subquery here. Okay, by grouping by department. So each department average salary you are taking, which is greater than 6,000, and you are returning that value outside. Okay, so here you are returning the department IDs. Like just if you can execute this, right? So these are the department IDs which are having average salary greater than average salary greater than 6,000. Okay. So then, so that department IDs is passed here. So for those department IDs, you are getting the salary and employee name and also department name, because in your select criteria you are getting details from employee and department table. So that is why the join is required. Okay. So definitely the key takeaway here is subqueries are useful when you need to filter or calculate something specific for from one table to use in another table, especially with the aggregates and conditions on small data sets. Okay, and similarly on the other side, so joins are generally better when you're combining or pulling related data from multiple tables and dealing with a larger data set. Okay, these are the keywords you need to understand where performance really matters. Okay, hope this particular video about joins versus subqueries was able to give some understanding when to use what and what is the crux behind using choosing one over the other. Okay, so if it is useful, please comment in the comment section and also share with your friends. Hope this was useful. Thanks for watching.